This video demonstrates the use of JSME. JSME is a computer program, and the letters stand for JavaScript Molecular Editor. This is a program that was written by Peter Ertl and Bruno Bienfait, and I hope I'm pronouncing those names correctly. But this is a really nice application, and if you visit many chemistry sites around the internet, you will encounter JSME as part of many of those sites. For our purposes, this is a chemistry drawing tool that allows students to draw molecules, and through the grader within edX, we can then grade those two-dimensional representations of molecules. So it's extremely useful for us in this course. Now, as with any drawing program, JSME has a palette of tools, and instead of having flowers or cars or airplanes in that drawing palette, we instead have parts of molecules. So there are bonds and rings, as well as different labels for different atoms in the molecule. So we're going to start with just a single bond, and I'm going to click in the drawing area, and up pops a bond. Now, all structures are created according to line angle notation. And by line angle notation, if this is a bond, at the end of the bond are two atoms, one up on the upper left and one on the bottom right, and those atoms are not specified, therefore those must be carbon atoms, and this is according to line angle notation. If you're rusty on line angle notation, please do visit the Khan Academy website. They have some great tutorials that will get you up to speed on reading these line angle structures. So we'll continue clicking, and as we click, since we have the single bond tool selected, we will create more bonds off of the different atoms in the structures. Now, we're not limited to single bonds, which is what we're showing. We can also do double bonds, and we can also do triple bonds. So we can very quickly create very nice structures. Now, when you're drawing, sometimes you make a mistake. There are a couple things you can do when you make a mistake. You can go press Control-Z, and that will automatically delete your previous drawing step. You can also click on the red X, and that will delete atoms from your structure. So those are two ways, Control-Z and the red X. So to continue looking at some of the features in JSME, we can add rings. We can add, here's a benzene ring. We can stick that onto the side or onto the end of a molecule. You can also, let's make this a little bit bigger, we can connect rings across the face of bonds. So we can add atoms to the end of a chain or across a bond as well to even fuse on rings. So this, again, this is a really nice tool to quickly create molecules. Once again, we're also talking about the line angle notation. So since none of these atoms are specified, they're all assumed to be carbon atoms. Very often in drugs we want atoms other than carbon atoms. So we can click over here, we can change from carbon to things like nitrogen. We can put in oxygens. When we draw these atoms, some or all these atoms may have hydrogen atoms connected to them. For example, this atom right here, that is a carbon group, and that carbon has 3 hydrogens. We do not want to show those hydrogens. We don't want to add hydrogens. JSME understands that there are hydrogens there. If we try to add hydrogens, and let's show how you would do that. I'm not advocating it, but let's show what I'm talking about. So we could say there are 3 hydrogens there, and let's label these as hydrogens. So we'll click on the non-standard atom button, and we have selected hydrogen. So now we can add hydrogens to that carbon. If you do this, it will alter the way your structure is graded. So do not add hydrogens. JSME will understands there are hydrogens there. We don't have to put them in special. The same goes for hydrogens on things like oxygen atoms. If we put an oxygen here, JSME knows that there must be a hydrogen on that oxygen to complete the octet of that atom. Now, of course, maybe we want a methyl group off the end, and that's fine. Well, we can stick a bond off there, and JSME will delete that hydrogen. But without the extra carbon, JSME will keep track of the hydrogens. The same is true for nitrogen atoms. If we have a nitrogen atom here, JSME knows that there should be a hydrogen placed in there. And if we delete a carbon atom, it'll say, oh, there must be 2 hydrogens there. So JSME keeps track of your hydrogens. Do not add them to your structure. So that's one thing that's important to keep in mind with JSME. Number 2, sometimes we will have charges on atoms. So let's put a carboxylic acid over here. And we'll drop in our oxygens. There's our carboxylic acid. Now let's say in the pH of blood, carboxylic acid will typically be deprotonated. So we can click on it and we'll switch that to a negative charge. This is actually a loop of different features. So if we click on it again, it'll assume, oh, you didn't want it negative, you must want it positive. And to be positive, you need 2 hydrogens on that oxygen. So again, JSME is very clever in how it keeps track of the charge state. But this is the way we can change charges. There's one final functional group that I want to talk about, and that is the nitro group. And let's draw out a nitro group as I would typically represent it. Let's see, we add the nitrogen. JSME knows that nitrogen must be plus, and as it turns out for the nitro group, we want this oxygen to be minus. That's the way I would show a nitro group, and that's I would consider the proper way to show a nitro group. But in many drawing programs, JSME included, if you continue drawing on the structure, it will refresh your structure and it will turn that nitrogen into a 5-bond nitrogen. Now I know that violates the octet rule, but for a chem informatics program, which is really what JSME is, that is an appropriate way to represent the nitro group. So don't be alarmed if JSME changes your nitro groups to look like something like this. I know as a chemist that seems terrible, but it's okay. The grader will understand this and it will still be accepted as a proper nitro group. Now there's one last thing that I want to talk about when we cover structures in JSME. The feature about JSME that allows us to use this as a tool for grading molecules that are drawn in this way is the fact that JSME can convert molecules into a SMILES notation. SMILES stands for Simplified Molecular Input Line Entry System. And what that means is you convert this 2-dimensional representation of the molecule into a line of text. And then we can grade that line of text. So if we click on the SMILE button, we get this string of letters and characters, and these represent this structure that we've drawn here. And from this string, you can recreate this structure. So there will be other times in the course where we will talk about SMILES, and this is what we're referring to as these textual representations of what we would think of as a visual structure. And this is an important representation of molecules that allows us to grade structures and communicate chemical structures more easily.